Accuracy and precision. Let's take a look at our kitten up top here to see what's accurate, what's precise, what's both. If we look at our kitten on the left, the goal is to get those mittens on her paws. Well, all the mittens have been tossed in the exact same area. So if you're able to reproduce your same results or measurements and they're very close to each other, we say this is precise. Now, it's not accurate because they're not where they're supposed to be. On the far right side, these mittens are a little bit closer to the paws, so they're more accurate. They're more accurate to where their actual value should be. However, they are all in different areas, so they're not precise. But if we toss the mittens in the same spot and they cover her paws, we are both accurate and precise. Looking at precision, the two numbers at the bottom have been measured with different tools. If I said which tool is more precise, you would say, well, the bottom tool is more precise, Mr. Grimm, because it went out more decimal places and has more significant figures. So if you're able to reproduce the same measurement over and over and over again and it's very close together, then you're very precise. Here we have two rulers, ruler A, ruler B. Ruler A goes by every centimeter. So if we're measuring this object, we may say 4.8, we may say 4.7, we may say 4.9. That's as precise as we can be based on our tool. But down here, ruler B, it goes by every tenth of a centimeter. So we could say 4.84, 4.83, or maybe 4.85. And you see, these measurements are closer together. We can produce measurements that are much closer together because this tool down here is more precise. That's precision. Accuracy is how close you are to the actual value. Let's say I measure something and I measure 14 centimeters the first time, then 13, then 15. My numbers are relatively precise. They're close together. But what if the actual value I was measuring was 75 centimeters? Well, then I'm not very accurate, but I am precise. We're going to focus on accuracy today. Accuracy is how close you are to an actual value. If you're measuring something, how close you are to that actual or accepted value. We know precision is how close your measurements are to each other. So again, this first picture of my basketball and rim, this person is neither accurate nor precise. Over here, much more accurate. The ball is closer to the actual goal, which is to be in the basket, but I'm not very precise. My measurements or my shots are all over the place. Bottom left, I'm very precise. All of my shots hit the top left of the backboard, but I'm not accurate. But our goal is to be both precise and accurate in the goal and every single time the same spot. Accuracy and precision. Now, if I'm measuring something and I'm 10 centimeters off, is that good or is that bad? Well, it all depends on what you're measuring. If I'm measuring a textbook and I'm 10 centimeters off, that's not very accurate. If I'm measuring from Zionsville to the Scoop and I'm 10 centimeters off, well then I'm very accurate. So it's all relative to what you're measuring. The way to figure out how accurate you are is by using the equation percent error. Percent error will tell you how accurate you are. The way we figure percent error is right here. You take whatever your measurement is minus the actual accepted value divided by the actual value and multiply by 100. That will give you a percentage, and that will tell you how accurate you are. Now in class, we want to aim to be 10% error or less. It's always in a percentage, that's your unit. If your percent error is positive, that means you measured your value too high. If your percent error is negative, That it means you measured your value a little too low. What it may look like is this. Let's say a student measures a 2.50 liters container to only be 2.38. So that was the experimental, or that was their value. The 2.5 was the actual value. Now we got to use our percent error equation to tell us how accurate we are. So we take whatever you measure minus the actual value divided by the actual value times 100. And if we go through that, we computation there, multiply, divide, add, subtract, we get negative 4.8% error. That negative means our value was lower than the actual value, but we're at 4.8% error. That's good. We want to be below 10% error in science class this year.